Hello, people of YouTube. So I'm here to have a little rant about my physics lab because I just finished doing. Well, finished. I did maybe 3 of them of like 6. I'll do them tomorrow before class. Don't worry about it. I just finished. Didn't finish. I just finished doing a couple of my pre-lab uh, questions for my physics lab, and the thing is that they were all about energy. Now, in terms of physics, what energy means is it's a measure of how do I explain it? Energy is essentially a measurement of the potential, or the not the potential. Okay, let's start with the basics. Potential energy is a measure of the potential an object has of doing something. So this iPhone 6, right now has potential energy. Because if you measure it from the floor of my dorm to it, it's maybe 4 feet. And so that's way too high. 2 or 3 feet, somewhere in that range. Between 2 and 4 feet. Actually, you typically measure in meters. Maybe 0.75 of a meter. Yeah, about 3/4 of a meter is its height. And so the way that you would calculate the potential energy is you would take its height, multiply it by the acceleration produced by the gravitational pull of the Earth by its mass. And that gives you a measure of its potential energy while it's sitting right here. When it falls, at each point, it has less potential and more kinetic energy. And what kinetic energy is the inverse of potential energy, where potential energy is the measurement of its potential for expenditure of energy. Kinetic energy is the measure of its current expenditure of energy. So as it goes down, up here it would have, let's say, 10 joules of potential energy. Down here, it might have 9 joules of potential energy and 1 joule of kinetic energy. And kinetic and potential always have that direct relationship. Whereas potential goes down, kinetic goes up. And then whenever it hits the ground and stops, kinetic goes all the way down. And then all this energy goes to 0. Because if it's at where you set your baseline 0 number at, of height, then you can see by the equation of mass times acceleration times height, if height is 0, the entire thing goes to 0. And then there's no more energy in the system. That is not always the case, because one thing that they try to drill into your head is this law of the conservation of energy, conservation of energy, which states that in a system that is unaffected by an outside force, the initial energy must equal the final energy. So in my phone example, the force that acts on it, that's outside of the system, is the ground, the normal force of the ground pushing up against the phone, which causes it to come to rest. And when it comes to rest, its kinetic goes to 0, and since it's at its 0 point, its potential goes to 0. So that force cancels out all other energy sources. Technically, the closed system would be, from the start, to just before making contact with the ground, like atoms distance apart is how you would measure it, because you would still consider it as its delta x, which is the change in its position, would be considered as being 3/4 of a meter, because it has gone from your initial of 3/4 to its final of technically 0, even though it hasn't really hit the ground yet. Because when it hits the ground, it goes to 0 meters per second, which is its measure of speed. Now, the kinetic energy equation is 1/2 mass times velocity squared. And velocity is the magnitude and direction of its speed. So the thing about velocity and speed that a lot of people get mixed up is that speed is what's known as a scalar vector. Scalar, that's wrong. It's not a scalar vector. It is scalar, not a vector. That's what it is. Scalar means that it has magnitude, but not direction. So a vector would be velocity, because that's if you consider it in one dimension of the x-axis. This way is positive, this way is negative. Yeah, this way is positive, this way. Okay. By convention, you consider right positive and left negative. So you would consider velocity, if it's going this way, to be positive, which would mean that, let's say it's moving at a speed of 5 meters per second in this direction. According to the vector of velocity, it would be moving at negative 5 meters per second. That was wrong. Positive, it would be moving at 5 meters per second in the positive direction, so 5 meters per second. If it's moving this way in 5 meters per second, then in concordance with the velocity vector, it has negative 5 meters per second. But its speed is still 5. And that's because speed is really the absolute value of velocity. Anyways, that's a very quick covering of energy and vectors a little bit. You're welcome. Physics is one of my favorite sciences, so I love to nerd out over this stuff. Anyways, the reason why I had a problem with that was because I know all of that because of my high school physics classes and because of my honors and AP classes back in physics back in high school. But I had this lab asking me these questions, and in my college honors physics with calc class, we haven't even gotten to this stuff yet. And this is the lab that's supposed to be in conjunction with this class. I only know this stuff because I've seen it before. There are people taking my class too that I know that have no idea what this stuff is because they just haven't seen it yet. And they're expected to be in this lab? I see a problem. I'm not saying it's a problem with the lab, because we're moving at the set pace dignified by our lab manual. And the thing is that when I go to class, odds are that because there's only one other person in my lab that's in my physics class, and odds are that just about everyone else except for me and her will have seen this stuff in their normal physics class. And to that, I say there's a problem. To which a solution is not an easy one to this problem, because it really does have to do with the speed at which my teacher has gone, which I have found to be rather lackluster. But I guess the thing with it too is that I do have my physics book. So if I don't know what I'm supposed to do here, I can just pop open the physics book and be like, well, mechanical energy is the equivalence of the initial energy equaling its final energy in a closed system. Excuse me, that was wrong. Mechanical energy is, in a closed system, the combination of an object's potential and kinetic energy. That is its mechanical energy. There are other things like spring and electrical energy, which I don't even remember all the nuances of electrical. I remember a little bit about spring. Spring potential is something to the effect of delta x times the mass times the spring coefficient. I'm going to Google that, see if that was right. Spring potential energy. Let's see here. 1/2 kx squared. So it's 1/2 times the spring potential times the movement of the spring squared. And so what the x is there is it's really the delta x of the end of the spring. So if you look at a slinky as a spring, if you consider this its resting position, and then you do that, the delta x, actually that was dumb. You consider this its resting position, and then you do that, the delta x would be the distance that I moved this to here. And then the coefficient, the spring coefficient, would be how elastic essentially it is and whether or not it falls or snaps back. Obviously, a slinky is not a good example of a powerful spring because its true resting position isn't very good. It's either that. Yeah, well, actually, it's not bad. A lot of the resting position with this actually does have to do with the friction between the slinky and my hand. Anyway, in a normal spring with a high coefficient, it's hard to compress or expand. So, do I have any examples here? Let's take this. Let's take my harmonica case. Fabric isn't always a very good example, but you can use it sometimes to explain. Yeah, that'll work. So your shirt can actually be used as an explanation of spring, because if this is its resting position, and that's expanded. The delta x is the difference that you moved it from this to that, or from that to this. Again, that's not a hugely great example, but with lack of a proper spring, it's the best that I can do. By the way, I have a harmonica. Maybe I'll play it someday. There, I played it. So, basically, my complaint is that there's this difference between where I'm expected to be in this lab and where I'm expected to be in my physics class. Because I'm ahead, technically, in my physics class because I know this stuff without the teacher even having gone over it. But in terms of my lab, I'm now behind. Doesn't that seem strange? Doesn't that seem wrong? It does to me. I don't know if it does to the one of you that's watching this. But just a little bit of food for thought. Like I said in the last one, just be careful. And if you ever have a problem like that, I would absolutely report it. I'm not going to report this because I don't really care. Another thing that I talked about in my last video. But if you really do have a problem like that, the best thing to do is to take it to like the proper authorities and be like, hey, this is a problem. We need to fix this. But I just wanted to rant about that. How I'm expected to be in two completely different places and two classes that are expected to be exactly the same in terms of or at the same spot in terms of the stuff that they cover. So, a little bit of food for thought. So, thank you for watching, and I'll catch you on the flip side.